that. No, now this is really good. Once I see it out and you're on it, then it has to go.
I think I like this.
Yeah, I got a few guys coming in already tomorrow. Bond's coming in, maybe a couple other football guys. So I'll be here. Yeah, I'll be here, FYI, tutoring. So here's what I'm going to do. Tomorrow after school, I'm going to tutor on I'm going to do the 3 problems that are on there pretty much. The parallel, perpendicular, or neither. And then the other one was graphing a line perpendicular to a line that's already on the graph, like creating a perpendicular line. So I'm going to tutor on that, show you how to do it. Once somebody's ready, I'm going to give them the retake. So I've had people do that. So far, nobody's gotten below an 80 when you do it right after it like that. And I want to say, I don't really even remember an 80. I only remember 100. But... I had no idea. Is it really? Yeah. Is your birthday today? No idea. You like literally wrote on her quiz how many days back it was. You can coordinate that. Does everybody want to sing happy birthday? It's Annalina's birthday. Is anybody in chorus? I want to hear somebody sing that can actually sing. I wish I could sing. Nobody? I marked you absent. Did you not hear me call your name? Amaya. Yeah, Amaya. What am I going to do with it? All right, I'll change it later. Because I don't want to go back. I'm recording now. All right, so here's your process. Unfortunately, you can't do the exact process on the exit ticket, but it shouldn't be that bad. It's not that bad. We've done it a few times. First of all, if you don't have it on a graph,
I got it right.
Put it on a graph. So on a quiz, my quiz really on the district stuff, you'll already have it probably. If they give you graphs or not on the district stuff, you might have to graph it, and I'd graph it twice because I have decided, and I think most people would agree, it is helpful for you to have one graph where it doesn't move. So like, I'll show you what I'm talking about. Create the original graph like that, like put the point on the graph. If you don't have one at all, if you already have one, you've already got it. But then do another one. Don't try to turn that unless you just know you have it down. Oh, I gotta flip it back around.
Use the back now.
Yes, you have. I want to make sure you have the rule, but I can look at the rule. Did you write the rule down? What happened to the X's and Y's? All right, then sit down. I need to see this because the second part of the exit ticket. Well, you try to write it down. If you get it, I'll let you go. All right. So I would have 2 copies of it. Again, if they already gave you 1 copy, you only need to make a second copy. If they didn't give you a graph at all, I'd make 2 copies of it. Again, might be tricky to do if you don't have 2 pieces of graph paper. If I'm in the room, I'll give you a whiteboard. Oh, that'd be good. You can have a whiteboard and just use the whiteboard for like the original and then turn your paper or whatever you want to do. Whiteboards would work great, actually. I didn't see that. All right, so now I need to know how far to turn it and which direction. Like that's step 2. What was step 1? Oh, put the point on the graph and label it. We really should be labeling it. I didn't do it on here, but it's not a big deal if you only have 1 point. It's a bigger deal when there's more than 1 point. So label it was step 1. Now, 180 is how many turns? 2, right? 90 is 1, then it's 290, so it's 2. 270 would be 3. So I take the whole graph. Hold on. There. Now I take the whole graph. 1, 2. That's my answer. Now, this is the trickiest part for some reason. You have to write the correct X and Y down.
3 and 5.
This is the way a graph looks. Ignore that there's negatives here now. Positives here. Negatives here. Positive here. That's not the way a graph works. You should know the way a graph works. Positive numbers up here, positive numbers here. Negative here, negative here. So you have to keep that in mind. If you need to scratch them out and just count, then scratch them out. Get rid of them if you continuously use the wrong numbers. And then just count. So if that's 0, 0, which way did I go to get the elevator when I went and visited my girl I almost married or went to the gym or whatever? Well, left or right to get to the elevator. So you go left or right first. So to get to here, I go to 1, 2. So my first number, I'll write it over here, I guess, is positive 3. Then I go up. So up is a positive number as well. Doesn't matter what's written on the printed graph. That is the number, or that is the answer. So, did you roll? What's the rule? You don't know what I'm talking about. So, now, second point you can get on the quit, on the exit ticket, is what is the rule? So I compare the original with, well, I should say the pre-image with the image. The easiest thing to see is, did they switch places? Did they switch? Yeah. So if they didn't switch, no, they didn't. See, this why you scare me. So I start with an X and a Y always, like that's what makes up an ordered pair, X and a Y. They did not change places. The 3 is still there, the 5 is still there. So I, again, just write X and Y. And a lot of people are messing up the next one because they're thinking about negatives and positives. It has nothing to do with, write this down, has nothing to do with negative and positive. It has to do with whether or not the sign changes. If it changes, it doesn't matter if it goes to negative or positive. It changed. If the sign changes, you put a negative in front of that value if it changed. So did the first number when it went here, did it change signs? Then I put a negative in front of it. Did the second number change when I moved it down? Then I put a negative in front of it. That's the rule. Went from X, Y to negative X, negative Y. Yes, there you go. So again, 90 degrees is a little trickier. So just know you got to be a little more careful, but I would always check for the rule. Did they switch positions? And then when they switched, did the sign change? And if it did change, you put a negative. If it didn't change, then you don't change it. Absolute positive to a negative, negative to a positive. If it changes sign, you put a negative in front of it. Because the negative symbolizes changing the sign, flipping the sign. It doesn't symbolize that, no, now it's always a negative number. I mean, nothing can always be negative. Like when you're rotating, you don't know where it's going to land. I mean, it might land somewhere where it's going to be positive, might land somewhere it's going to be negative. It can't always be negative. All right. Any questions on that? That's your exit ticket. We'll probably do one more right before the exit ticket. Pretty much just like this. Yeah, last 5 minutes. All right. Next question was, how many degrees total in a rectangle? What's the answer? Say it again. Not 180. How many angles in a rectangle? How many corners? How many degrees in each corner? So total of 360, right? 90, they all have 90 degrees, right? 90, 90, 90, 90. 360. Right, so first of all, 360 degrees in a rectangle. So if this is all the proof that I do on this, because I used to do more on it. We don't have time these days. If I take a rectangle, oh, by the way, a square is a rectangle. So I get all the time, a square? No, a square is not a rectangle, it's square. Nope, it's a rectangle. Just a rectangle where all the sides are the same length. It is a rectangle. So if I take a rectangle, square, whatever, and I divide it exactly in half, I'll create 2 equal triangles. Like they are the exact same triangle. What's got to be true about the total degrees then in one of those triangles? Got to be half, right? If I take 2 equal ones and I started with 360, then they have to remain equal. So those triangles have 180 degrees. That would be the same case down here. That would be the same case for any 4-sided figure. So make these 2 quick notes. Well, one note. All 4-sided polygons, which is just straight sides, Polygon just means it's got four sides. So these are polygons, but it doesn't have to be that it's like nice and symmetrical. It could be something like this. That is a polygon, four sides, four straight sides. If I were able to, and there are proofs again behind this, but if I measured all the angles perfectly, they would always be 360 degrees, every four-sided piece. And even if I can't make two congruent triangles, every time I divide one of those into two triangles, the triangles will always be 180 degrees. So we're about to do just some rules. Actually, I'm going to move this over a little bit to give myself some room. So turn to page 272, maybe? No, 274. The lesson starts on 272. This is on 274. I'm going to create something up here that you may want to create in your book. I would say create in your book. But you need to be careful. Hold on. I'm going to just skip. I didn't do this in other classes, but let's just skip to, I'm recording. So again, this is page 274, down at the bottom, 274. Okay, just confirm that if it's not 274, let me know. So I'll just do it in this class. That's since I'm recording. I'll do it from the book page. So first definition, interior angles would be where? Inside the triangle. We've said that before about interior. So you have three interior angles for a triangle. Here's your first equation. This is your, again, fireworks, exclamation points, capital letters kind of thing right here. Every triangle, and we just said it, but I'm going to write an equation for it now. Every triangle, I don't care what it looks like, if it is a triangle, the three interior angles add up to 180 degrees. Again, that is your number one, so like exit ticket type question. Not today, but probably this week. Those three angles have to add up to 180 degrees. Always, no exceptions for triangles. All right, so there's your first thing to write around that picture somewhere out to the side. Then we have these things called exterior angles. So I'm going to need to slide that down a little bit. So an exterior angle is if you extend one of the sides of the triangle out past the triangle, like outside basically the triangle. That creates an exterior angle. So 4 is an exterior angle. Now there's an exterior, really there's two exterior angles for every angle, every interior. It just means that you've made like one of those semicircle things. Like you got linear pair, basically. You're going to create, you can create that for every interior angle if you extend the side. So if I wanted to extend this side out, actually I think I have this in here. Which one? That one, I think. So if I extended that side out, I now created a linear pair for 3. So we'll call that one 5. So that is an exterior angle. Oh, thank you. What was that? Uh-oh, who's been bad? All right. What? Thank you. I'll let you come in later on. And then if you've already figured out what I'm going to do, I'm about to extend the other one. Which one is that? I think that's this one. Nope. Whoop. There we go. So if I extend that side out, I now create an exterior angle with 1. So there are 3. Now I could have extended them the other direction. Like instead of making this side go out to the right, I could have made it go out to the left and create an exterior in that direction. So just understand, sometimes you could see more than 3, but typically we'll only deal with 3 at a time within a problem. If we get to more complex figures, that could change, but we'll worry about that when it happens. So here's your next rule. The exterior angles of a triangle. And this actually turns out it's all figures, but we'll deal with triangles now. They total 360. And really, any polygon, the exterior can be 360. But we'll get. So the last one, and definitely the trickiest one. I mean, that one's, kids forget that one a lot. Hopefully you get actually, you're going to do a bunch of IXLs on both of them. So I'm hoping you don't, at least short term, I'm hoping you don't forget either of those. So the last one has to do with the relationship between an exterior angle and 2 of the interior angles. I'm going to briefly explain it. If you don't get this, don't worry too much about it. So if I add up those 2 angles, what's true? Daniel. See if you hint by doing that. Well, the 2 I did the semicircle thing. Those 2. What's that mean when I do that? What's got to be true about 2 plus 4? Have to add up to 180, right? Well, that's true of all of the places where I have an exterior and an interior right next to each other. But what did we say is true about all triangles in the interior? They also add up to 180, right? So that means that this angle plus 2 is 180. But also 2 plus 1 and 3 is also 180. So it's kind of like that transitive property of A equals B and B equals C, then A equals C kind of thing. That leads us to our last, and it's actually 3 equations, but they all say the same thing. An exterior angle, so angle 4, is equal to the 2, it's called remote in your book. So we're on this one right here. I'm going to say opposite, but whatever words, I don't think the definition of remote will ever come in. Just know it's the opposite to interior angles added together. So that's the exterior. The 2 opposite interior are 1 and 3. So 4 has to equal those 2 added up. So Kingston. Wait, that's not Kingston. Yeah, Sean. I can't tell. They all. That's Sean. Sean. Yeah, that's Sean. Wake up, Sean. Peyton. So what would? I did not mean to erase that part. Well, we'll do that. So what would angle 5 be equal to then? With that same concept of what 4 is equal to. So you know you're just digging yourself a hole when you do that. No, that's not what I'm talking about. What do I say about you? Low key? Low key? Yeah, see? Every time you do that, I'm like, yeah. All right, Sean, hold on, Sean. Hayden. Oh, come on. You're not getting off that. 4 was equal to 1 and 3. 2 opposite interior. So 5 is equal to what? 1 and 2. So 5 is equal to angle 1 and 2 added together. And well, I was going to call him Tommy, but not in. Javon, finish it off. So angle 6 is the only one I have left, the only exterior I have left. Oh, Tommy, got back. So the 2 opposites. So that's the last rule. You get all those rules down, That covers like 95% of triangles. Until you get a really complex figure that has more than just triangles going on. Ah, 54. Get out of 54. Huh. You got them way early. Wait. No, I'm just kidding. What's your question? I was just joking. What's your question? No, we're gonna practice for it. So you'll get a bunch of practice in this time. No, right, right. That's not even the exit.
I'm just saying for the rules so I had to memorize.
No, because I get in trouble when you don't write things down. They don't want you just taking pictures of stuff. I'm not getting in trouble for you. If there weren't rules to follow, I wouldn't. Hey, whatever. But there are rules I have to follow, man. You don't seem to understand. You think I'm making all this stuff up. They do not. They want you writing notes and then going back and using. I know you're not going to go back and copy it down from your phone. That'd be one thing if I thought you'd do that. But you have to have notes that you can use later in class. So you're still not writing it down, so I guess it's not helpful anyway. But I'm not going to give you that option because then you always take it. Start writing stuff down. You've written nothing down. Why are we so far ahead? Yeah, I don't know. Again, oh, I know. One more thing. Oh no, we did that. All right, here, do this then. I did do this in one class. I didn't get to it in one class. So we got that. We got this. And we got this. Write an equation. Think about what you just wrote as the very first rule on the other page. Think about what I just wrote and create an equation. Doesn't matter that there's not any specific numbers and there's still some missing stuff. No, see, it's like right. Got it right. So, I don't even know what they expect to do with us to do with you guys when we don't write anything down. Oh, that's exit tickets. Let's see which one. That one goes there. What is this? That one goes there. All right, so raise your hand. I'm going to do this real quick because I want to start practicing the exit ticket. Raise your hand if you're like, yeah, I got that. Like, I just looked at the equation we just wrote and I just copied in what angle 1, 2, and 3 is because that's all you're doing. It does not matter that we do not know what this number is. Doesn't matter that we don't know what that is. Doesn't matter that we don't know what that is. Those three things added together have to equal 180. Now, light bulb. Light bulb. So, and this is how you set equations up to solve. Like, this is where we're going to when you do the IXLs and other stuff. I take, and it doesn't matter which one is angle 1, angle 2, angle 3. I take those three things, I add them together, and you're a man. And now I can solve not only for x, but if I solve for x, I can plug it back in and solve for any angle. Write this down. I forgot to say this in second period. Maybe this is, or maybe fine. This is a big, big lesson. Triangle, just all triangle stuff and really angle stuff again. Make sure after you solve for the variable, you read the question. I will sometimes say solve for x. Like that would be the question. That's pretty rare in like the book stuff, the EOC district stuff. They're gonna ask you, hey, what's the measure of angle B? What's the measure of angle A? What's the measure of angle C? So if you don't finish the problem and answer it, you're gonna get it wrong every time. You got to solve for x, and then typically you're going to plug it back in. So make sure you read the question. Anybody actually did it? Oh, what would that be? 70, 16 point what?
Like 3, 6, but I'll round it up.
And then you can say, okay, well, if I want angle B, I'll plug it. Now, keep in mind when you round and you get, like if you did all three angles and then you added them back together, they won't equal 180 because you rounded. Like you didn't use exact numbers. So there's no way they're going to add up to exactly 180 when you do these kind of problems. But we'll talk about that more when we do. All right, so I'm have some graph paper out. We're going to do a couple practice problems for the exit ticket. At least one. We may get two in this class. Um. I guess we could just do that one. Yeah, we've already done it, but I mean, it's stop it. This was the bell work the other day. Are you kidding me? What in the world? It's just a matter of reminding you of the process is all I'm trying to do. So again, process is number step one. What is it? Put the point and label it. If there's multiple points, you have to label it. If it's one point, it's not gonna really matter because you only have one point. You can't get confused if there's only one point. But because sometimes the points may start left and right, but then when you do the, it could be reflection, rotation, whatever, they could change sides. You need to know which one was the original, like A or B or whatever. So that's your first step. So go ahead now, try to do the rest of it on your own. If you want to try to do it with, like, if you have extra graph paper, like if you have 2 pages and you want to try to like kind of use both of them, I will start. Oh, we're kind of already done with this lesson, but maybe actually, if you want a whiteboard, just raise your hand. I'll give you a whiteboard right now with a graph on the back. If you think that will help you, so you can keep one still and rotate one. Raise your hand just so I know how many you grab. Anybody else? I think you got it down, Bill. The only hand I saw, right? Anthony, here, bud. Here, bud. All right, so I'm going to go ahead and do one so we can probably get it. Yeah, we should definitely get another one. So we take the original point. I would, again, if you need to, make a copy of it. So you have two of them right next to each other, exact same. I did it. Exact same graphs right next to each other. Again, can't really do that on the exit ticket unless you have a whiteboard, but if you don't need to, you don't need to. So now we're going to take that image and we are going to turn it how many turns? Yeah, 90 is one. Which direction is that? Show me with your hands. Spin it around. So again, if this is clockwise, I reverse it and then I just keep going as I go to my graph. So that way. Should have been going that way with your hands, fingers, whatever. Ah. I turn it once. Oh, my board. I oh, that transfers. Now, again, ignore the printed numbers. These are not positive numbers on a normal graph. That's the way a normal graph looks. Negative, positive, positive, negative. So you got to know those are negative. Like I said, if you need to, get rid of them and then count. Those are not negative. The y's are okay. Bottom is negative, top is positive. So I go from that to 1, 2. So that is right over here. -2. Oh, X is always first. Got to walk to the elevator first before I go visit a woman I almost married or gym or pool or wherever I was going. Then I go down 1, 2, 3. Well, that would be a negative Y. I transfer. And make sure you write this on the exit ticket. You don't even have to put the point on the graph. I don't know what the wording is on it. It might say put the point on the graph, but I want to make sure you write the ordered pair because that's how you find the rule out. So now we take the original ordered pair. -3, 2. And we say, okay, well, what happened? What happened to my x and my y? The easiest question is the first question. Maya, did they switch order? Did they change places? They did, right? So I already know that I'm switching the order. That's easy. Now the next part's a little trickier. You got to say, okay. So when I change the order and I move that to the back, did it change signs? Did it, right? So the one that I moved to the back, I don't touch that. It didn't change signs. So when I change the order and move that to the front, did it change signs? Well, then when I moved this to the front, it changed signs. Doesn't matter positive, negative. Did it change signs is the question you have. And it did, so there's your rule. Negative y comment. Like that. Well, they would give you that. Normally they'll do, well, the rule is always with variables. That's what the rule is. Yeah, you're using numbers to figure out the rule. Just like when we did reflections, we said, if they don't give me a point, I can just create a point. Same thing in rotations. They may just say, what happens to x, y after a rotation 90 degrees counterclockwise? They may not give you a point at all. They may just say, what happens to a point after you rotate? We'll just pick point. Just do what we did with reflections. Pick, again, I would still pick 2, 1. That one works pretty well in rotations also. Pick 2, 1, rotate it, write the new point, and then do what we just did here and see what happened to find the rule. They want me to give you the sheet with all the rules. I don't like that because you're not going to remember. I mean, you might remember it for my quiz. You're not going to remember it for any of the district stuff, certainly not for the state stuff in 5, 6 months. But if you can figure it out, that will stick with you. And I think most of you are in pretty good shape on that. All right, let's do another one.